All right. Now we're going to look at, okay, up until now, what have we done? We've graphed lines. We've figured out equations of lines. We've figured out slopes and distances, all with lines. Now let's go one step further. Let's look at how we're going to dissect linear equations. Linear equations as functions, and then we're going to find their zeros. We're going to describe what all those mean in a minute. First off, what is a linear equation? Remember, mathematicians are not too ingenious when it comes up to names. It's an equation that defines a line. Yes. Now, looking at it, how can we tell it's an equation of a line? There are two things we look for. Very good, very good. That's the first one. Because it has to be an equation. And then how do we know it's going to be that of a line? The variables do not have any special operations. Performed on them. Meaning there's no exponent, there's no radical, there's no absolute value, there's none of that stuff. It's just X and Y and some numbers. What's a function? You've heard these terms before. Most of you in the 6th and 7th grade, and then there on out. What does a function look like? Who's never seen a function before? Nope. All of them will have domains and ranges. Again, I want to know what you know, not what you can read. Don't go looking for it anywhere. That's what you should be doing outside of class. A function represents an equation. A linear equation could look like this. That's an equation. But a function will look like this. It signifies two things that this notation doesn't. The name of the function and the only variable inside the equation. In other words, the independent variable. So whatever occurs inside this parenthesis is the only variable that belongs inside the equation. Well, not the only variable, it could be other ones, but whatever that one is, whatever number you put in place of that, that's the only thing you replace. How do you read this? Yeah, it is read the function f of variable x is. And we just shorten it, say f of x. So if I give you this equation, in order for you to be able to tell me what y is going to be, I have to say when x equals, let's say 3. So now once I define that, I go here and replace the x with the 3. Y equals 11. As opposed to, if I use the function notation, everything is right there in one swoop. I don't have to define what x is because I defined what x is right there. Anything inside the parenthesis is my x. So this tells me anywhere I see an x, put a 3. It's going to give you the same answer. But it makes it a little bit easier for us. What do these represent? When we solve an equation, what does that represent? A point on a graph. So what's the point of this graph? Remember, you have to have an x and a y. So what's the x value? X was defined up here. And then what's the y value? Yeah, so yeah, I'm glad you said that, because now you have to go looking for x and y values. Here, it's all there. This is your x, this is your y. Because y and f of x represent the same thing. It's the y value. It makes it much easier just to look at that. Now you may say, well, what's really the big difference? Well, if I give you multiple functions, I can now make it easier for myself. I don't have to keep on rewriting the equations all the time, or x equals for each one separately. Now I could differentiate which function am I referring to at each point. And how would you solve this? Well, we have 3 terms. What does f of 0 represent? Well, there's a function name. In place of x, I put a 0, so I have 3 times 0 plus 2. That's 0. So f of 0 is 2. G of this one here, g of 2, g is 5x. So anywhere I see an x, I put a 2. So g of 2 is 10. And here's h. I go to this function. Anywhere I see an x, I put a 2. So h of 2 is equal to 4. Now, once I work those out, I just go back here and plug them in. F of 0 is 2. G of 2 is 10. And h of 2 is 4. Now work it out from there. 3 times 10 is 30. 30 plus 6 is 36. So that's the benefit of using functions. They're interchangeable. Sometimes we'll use functions, sometimes we'll use y equals. All right. We have two basic properties that we have to abide by. The addition property because now we're going to get into this whole section deals with solving equations, solving functions, solving equations. If I have two variables, if a equals c for any number a and c, if I add something to the left side, I have to add the same number to the right side to make it equal, to keep the equality because of the balance. So that's the additive property. Does it also work for subtraction? It works the same way. And then we have the multiplicative or the multiplication property. That says the same thing. It says if a equals c, if I multiply anything to a, I have to multiply the same thing to c to keep equality. So you're saying, duh, no problem. It's just obvious. But why do we use these? To solve linear equations, I'm going to use LEs from now on for linear equations. We use the process of opposites to solve for a variable. The procedure, the process in which we do these, we know the order of operations says do special ops first, then do multiplication, division, and then do addition, subtraction, all going down this way. That's when we're simplifying. You get rid of the parentheses first, the brackets, whatever. Then you do the multiplication division, then you get addition subtraction. When you solve, you go the opposite direction. Except special operations has to be done first because we have to get the parentheses out of there to get everything inside there. But once we finish that, we get rid of any pluses and minuses, and then any multiplication divisions. For example, x plus 3 equals 5. No special operations. You're solving for x. How do we know we're solving for x? It's the only variable in there, and it's got an equal sign. If there's an equal sign, that means you're not done until something equals something. So, in other words, what this says, since we're solving for something and x is the only variable, we're solving for x. X plus 3. Get rid of whatever that variable is we're looking for. Whatever's added or subtracted to it, we get rid of it first. How do you get rid of a positive 3? Minus 3, because it's the opposite. Whatever I do to this side, I got to do it to that side. Let's try 3x plus 5 equals 2x minus 6. Okay, now you may be situated with something like this. You have x's on both sides. Again, you're solving for x. It's the only variable there. So what's the first step? We have to move all the x's to one side. So we have to have x's to one side, non-x's on the other side. And it doesn't matter which side they're on. It's going to be the same answer. Why do I say that? What would you do here? And why? Your school book's good for something. Good catch. Thank you. Yes, we have to combine all of our x's to one side and everything else on the other side. So where are we going to move the x's? To left or right? Okay. How do we move? So this one's already, we have to get rid of this one. Move the x's first. Do not move the numbers first. So 2x, how do we get rid of 2x? Subtract 2x. So those cancel. 3x minus 2x is simply x. All the x's to one side, so non-x's go to the other side. Get rid of 5. We subtract 5. So x is equal to negative 11. Now, this is the only time where you should know your grade before anybody else sees it. Because once you define what x is, you can check it, see if it's right or wrong. A lot of people don't do that. How do we know this is the right answer? Plug it back into the original equation and see what happens. So we have 3 times negative 11 plus 5 2 times negative 11 minus 6. Positive times negative, 3 times 11. Positive times 11, positive times negative is negative. 2 times 11 is 22. The signs are different. Take the sign of the larger. 33 minus 5, negative 28. They're both negative. So add the numbers. 22 plus 26 is 28. Because these are equal, we know that's a valid answer. Try to get used to checking your answers. It's going to be extra work, but again, it'll save you work in the long run. You don't have to do it over. Okay, so let's look at another one. Similar to that. If you want me to turn the page back, just tell me. If I'm flipping too fast, I'll slow down. How about this one? What do we do here first? Which one? You're going to add x's or subtract? So which one we move in? 2 or 3? Okay, I'm sure now. No, but let's see. I'll show you why. Because if you move the 2, how do you get rid of that 2? You have to subtract. So you're going to have a negative in front of the x. So to stop trying to have negatives anywhere, always move smaller x to larger x. Which one's smaller, negative 3 or positive 2? Negative 3. No, I mean, you still got cockroach in your head. So we'll look at it both ways. So let's move like you said first. 5 minus 3x equals 2x minus 8. So you're saying do this. So we have 5. They're both negative. 2 plus 3 is 5x. All the x's here, so I get rid of the 5. They're both negative. 8 plus 5 is 13. Now try to keep away from dividing by negative numbers. Because you see all these lines that are everywhere, you'll get confused eventually. So whenever you get this situation, just change the signs across the board. And then divide by 5. Treat the signs and the numbers separately. The answers are going to be what the answers are going to be. It's just that the less work you do, the less chance of mistake. Now, if we do it the other way, move the smaller to the larger. Negative 3 is smaller than 2. So I add 3 to both sides. 2 plus 3 is 5. Add 8. And then divide by 5. Now, at this point, if you want to, you can flip them. But this side here has a lower chance of making a mistake with the signs than this side. I've seen it thousands of times. So you can do whatever you want to. It's just that try to keep away from dividing by negatives. Let's look at some examples because we haven't even gotten to fractions yet. Let's look at example 2 first. Positive 2 times 5 minus 3x equals 8 minus 3x plus 2. So order of operations says do what first? Yeah, can we do anything inside the parentheses? No, because they're not like terms. So if we can't do anything inside the parentheses, we have to get rid of the parentheses by distributivity. 2 times 5 is 10. Positive times negative is negative. 2 times 3 is 6. X equals 8. So negative times positive is negative. 3 times x is 3x. Negative times positive is negative. 3 times 2 is 6. As a general rule, whenever you get rid of parentheses, the first thing you want to do is combine like terms. Because what that just did is just opened up a whole new set of numbers. So we can combine these two numbers. 8 minus 6 is 2. Which x do we move? Why? How do we know it's smaller? Left. The further left the number is on number line, the smaller it becomes. So that's why we get rid of 6 first. How? By adding 6x. You have opposite signs. Take the sign of the larger and subtract 6 minus 3. All the x's are on one side, so get rid of the non-x's. Subtract 2 from both sides. 10 minus 2 is 8 equals 3x. Divide by 3. So x is equal to 8 over 3. The computer will take that as an answer, but common convention mathematics says no. It's improper. Keep on going. How many times does 3 go into 8? With how many left over? Yeah. The way you do it is 3 goes into 8. 3 goes into 8 2 times. 3 times 2 is 6. 3 does not go into 2. So this is your remainder. That goes on top. This is your denominator. It stays on the bottom. And this is how many times it fits in there. What's that called? A mixed number, because it's made of integers and rationals. Remember I said, check your answers? Let's go ahead and check our answer here. Always check your answers. So we're going to test this in the original equation. 2, 5 minus 3x equals 8 minus 3x plus 2. Let's plug in that number into x. So everywhere I see an x, I put the 8 over 3. Yeah. Order of operations. Can we do anything inside this one? Yes. the threes cancel. So in this first one, we have 5 minus 8, since the threes are gone. We could go ahead and combine these two. We add the two fractions. Or since the leading coefficient is the same as that, we could distribute. They both give us the same answer. So we have -3 times 8 over 3. And then -3 times 2. Just the threes here cancel. So we have 5 minus 8. 8's bigger than 5. It's negative. 8 minus 5 is 3. So we have 8 minus 8. 3 times 2 is 6. 8 minus 8 cancels. So we get -6 equals -6. What happens if this doesn't equal? What do you do next? Go back in on a separate piece of paper, try it again. Maybe you made a mistake here. And if that still comes out different, the same answers you got earlier, then go back to the original question and resolve it. Any questions so far? Let's look at example 1. 3/4 x minus 1 equals 7/5. Whenever you have fractions and an equal sign, get rid of the fractions. And these next 5 steps are going to be used a lot throughout this course. Here are our steps. First step. Find the LCD of the equation. Least common denominator. In other words, what's the smallest denominator? What's the smallest number that the 4 and 5 both fit into? Yeah, if you don't want to take time thinking about it, just multiply them. 4 times 5 is 20. Because if it's something smaller than that, it'll come out in the end. So that's our first step. We found the LCD. Second step. Well, how many terms do we have in our equation? Well, first off, what is a term? We heard the word a lot in math. What's a term? Anything separated by a plus, minus, or equal sign. So how many terms do we have here? 1, 2, 3. Yeah. So second step. multiply the LCD to each term. So we have 20. Put the terms inside parentheses. Minus 20 times 1 equals 27/5. I multiply the LCD to each term. The rule of fractions says whenever you're multiplying two fractions, what's the first thing you do when you multiply two fractions? Always reduce. A lot of students were taught multiply top by top, bottom by bottom, and then can't cancel. No, it's ridiculous because the numbers are big. It's best to get them smaller while they're small. Reduce. Can anything on top cancel anything on the bottom? So here we have, this is 20/1, 20/1, 20/1. If you have any fractions, this is where they all disappear. 4 goes into 20 5 times. 5 goes into 20 4 times. So we have 5 times 3x, 20 times 1, 4 times 7. Looking at those two equations, which one looks easier to do? The bottom one, yes. And it's just exactly the same equation, they just look different. So that's our objective. Get rid of the fractions. It takes away some of the anxiety for some students. So we reduce first, we just did that. Fourth step, multiply to remove the parentheses. We have 5 times 3 is 15. X. Negative times positive is negative. 20 times 1 is 20. 4 times 7 is 28. No more parentheses. The last step is solve. These 5 steps are always going to be used whenever we have fractions and equal sign. Like we just talked about, there's x's on one side and on the other side, so we get rid of 20. Since it's a negative 20, we add 20. (15x equals 48). And then divide by 15. You don't have to, by the computer, you don't have to turn that, this is an improper fraction because the bottom is smaller than the top. You don't have to put it into a mixed number, but you do have to simplify. (15) is made up of 5 times 3. Does 5 go into 48? No, because if it's divisible by 5, it has to end in 0 or a 5. So it's not. How about 3? Does 3 go into 48? Here's the easiest way to determine. If a number is divisible by 3, for example, if 48, if it's divisible by 3, the way you test it is add up all the digits on top. And if that number is divisible by 3, then this number is divisible by 3. So if you want to divide something by 3, add up the integers of that number first, and then see if it works. If it does, then it's divisible by 3. So 3 goes into 4 how many times? Once. With how many left over? 1. 3 goes into 18 6 times. So 48 over 50. This becomes that. And there, if you want to then we could put 3, 1 over 5. The bottom number always has to be done about. What I'm trying to get to is you don't always have to use your calculator. Decimals, the rule of mathematics says this: if your question starts off with fractions, you're going to end up with fractions, not decimals. So learn how to, or relearn how to do decimal manipulations. Example 3. Negative 24x plus 7 equals 17 minus 24x. We have x's to both sides. So we add 24x to get rid of one of the x's. Well, so just so happens it gets rid of both of them. Here, if all variables are eliminated, and the remaining equation is false, then there are no solutions possible. No matter what x that you'll put in the equation, it'll never equal. So this one has no solutions. So after you do all the algebraic manipulation, if what you're left with is an equation with no more variables and it's not correct, then there's no solution. Conversely, example 4, 3 minus 1/3 x equals negative 1/3 x plus 3. Okay, for practice, remember you have fractions and equal sign. So the first step is the LCD. What's the LCD in this example? 3. Yeah, 3 is the only one. So how many terms do we have? 4. Here's 1, 2, 3, 4. Multiply the LCD. So we have 3 times 3 minus 3 times 1/3 x equals 3 times negative 1/3 x plus 3 times 3. Multiply to get rid of the parentheses. 3 times 3 is 9. Oop, reduce first. So the 3's cancel, so we have negative 1x. The 3's cancel here, so we have negative 1x. 9. This one should have been reduced. Now, and then it's multiplied to get rid of the parentheses. And then solve. So we have 9 minus x equals minus x plus 9. Add x's to both sides. So if the variable is gone, and the remaining equation is true, then you have infinitely many solutions. Infinitely many solutions. What does that mean? Yeah, any x you put in there, it's going to work. There are no restrictions. Okay. Now comes the part of the class where you guys will not like it that much. It's word problems. Let's apply with what we just discussed into math. Example 5. Example 5. Let's look at this. Words in languages. So when you read each sentence, translate what that means into either numbers, equations, formulas, or whatever. There are about 232,000 words in the Japanese language. So the Japanese language has 232,000 words. Instead of looking for it, just go ahead and it's on the board. Don't waste your time looking for it. I'm not going to stop. The second sentence. This is 19% more than the number of words in the Russian language. Uh-oh. 19% more than the words in the Russian language. How do we put that into math? We have to translate what that word says, though those words mean in that sentence, into a math statement. This is, what is this? What this are they referring to? The number of words in the Japanese language. So this is 19% more than the words in the Russian language. So how do I put that in math? So The Japanese language, 232, is the word is reference equal sign 19% more than the words in the Russian language. So you have the number of words in the Russian language. More than means what in a math statement? Is it a plus, minus, times, or division? It's plus. 10 is 5 more than 5. So far it says this is Japanese language is 19% more than the Russian language. So Russian language plus what? What 19% of what? Yeah, the words in the Japanese language, right? The 232,000. So the Japanese language has Russian language plus 19% of the Japanese language. So let's put this into more manageable words. 19% percent really means 1/100. And so this divided by 100. So move decimal. So it's 0.19. Or yeah, you said 19 divided by 100. The word of, whenever we deal with math of percentages, of means multiplication. So what we have right now, let's put in all the numbers that we know. We have 19 over 100 times 232,000. Since this is multiplied, these two are multiplied, it's one big division. The 2 zeros can cancel the 2 zeros there. We have 19 times 2320. The Japanese language has 2320000. So we have to get rid of this number. So we subtract 19 times 2320. So what is 2320 times 19? 18.8 0232. So it's 232,000 minus 23200. So the Japanese language, I mean the Russian language, has 208,000 words. Yeah, always whenever you do this, because it's like exercising, is check it with a calculator. Once you work it out, check it with a calculator. Yeah, and use your calculators to supplement your education, not replace it. All right, now the next one. Convenience stores. This is example 6. In 2014, there were 151,282 convenience stores in the US. So that's the first sentence. That was this. The total number of convenience stores in Texas and California was 26,379. So how do I write that down? The total number of convenience stores in Texas and in California was 26,379. Texas and California, the number of stores equals 26,379. So this is typically what's going to happen. It's going to give you the overall equation that you're going to use. But we have one equation with 2 variables. How are these 2 variables related? That usually comes in the next sentence. There were 4,003 more stores in Texas than in California. How do I put that in math? There were 4,003 more stores in Texas than California. Are they equal? Who has more? So how do I make them equal? If Texas has more, what do I have to do to California? I have to add the 4,003 to make them equal. Because if Texas has 4,003 more stores in California, then I take the number of stores in California, add 4,003, that's the number of stores in Texas. So here's the equation that I have to use, and here's the relation. Because if you add 4,003 to Texas, then you still have more in Texas than California. Because Texas has more stores than California to begin with by 4,003. So because of the inequality, this one is Texas has the same number of stores as California plus 4,003. So to make them equal, I had to add 4,003 to California. Yeah, the reason this is the most difficult part for a lot of students is because you're never taught to read for specific information. Yes, exactly. This is just an ancillary piece of just general knowledge trivia. Because if you think about your history classes, your philosophy courses, your history, your English, you're always asked the general content, not specifically what each person does, but what is their part in this play, not specifically how they change it. And that's what we have to do here. We have to find the general overall picture, and then how are they connected? Now we connect these 2 together. So anywhere I see a T, I put a C plus 4,003, that's the T, plus C equals 26,379. Oops, I'm sorry. So now I only have one equation with one variable. Combine like terms, C plus C is 2C. subtract 4003 from both sides. Nine minus 3 is 6. 7 minus 0. 3 minus 0. 26 minus 4. And then divide by 2. Two goes into 2 once. 2 goes into 2 once. 2 goes into 3 once with 1 left over. 2 goes into 17 8 times with 1 left over. And 2 goes into 16 8 times. So California has got 11,188 stores. It just takes practice. You have to first read the statement, first the sentence, and it's going to give you an overall equation that you have to deal with. And then you have to look for a specific connection between the relationship between the variables. Any questions? All right, so let's now look at some application problems. Well, first off, we're going to look at motion problems. Motion problem involves movement. Whenever you talk about things that move, you have to deal with time. So here we deal with the distance equation. Unlike the distance we had in chapter 1, where the Pythagorean theorem, the square root of x squares plus y squares, what this one says, the distance something travels is related to its rate, or the speed of which it travels, times the length of time in which it travels at that rate. When we deal with word problems, we also deal with units. What is the unit of speed? Yeah, well, typically miles per hour. So it's miles per hour. So in that case, what unit is time? In this case, it's got to be hours. If we cancel the hours, that means distance is in miles in this case. So the formula we use is distance equals rate times time. If you wanted to find the specific rate something is traveling, remember, rate is miles per hour, or feet per second, or light years by years. Yeah, so to get solved for r, we divide both sides by t. So it's d over t. And likewise, if you're solving for time, get the t by itself, divide both sides by r. Depending on what you're looking for, you can solve it from that equation. Example 7. Example 7 is a typical one students see on standardized tests. You have two airplanes leaving the same airport going the same direction, but traveling at different speeds. Delta Airlines fleet includes Boeing 737s, each with a cruising speed of 517 miles per hour. So let's put that down. We have, this is the airplane A. It's a 737. Its speed is 517 miles per hour. The second airplane is the Saab 340B. And it has a cruising speed of 290 miles an hour. So this is the 340, and it has 290 miles per hour. Suppose that the Saab takes off and travels at its cruising speed. Then 1 hour later, the Boeing 737 takes off following the same route and traveling at its cruising speed. How long will it take the 737 to overtake the Saab? So what exactly is this one looking for? How long? So is that D, R, or T? T. So we're solving for T here. And it's whenever you deal with these type of problems, you can create charts. You have the plane. You have the distance it travels. You have the rate that it travels. And the duration of that rate travel. So we have plane A, which is the 737, and then plane B, which is the Saab 340. So what do we know in this equation here, in this table? Do we know the distance? No, because the question is asking how long till they overtake. So basically, so they're both starting from the same airport. And then the Saab takes off first, and then the Boeing takes off. They want to know at what point, when do the airplanes equal? Put your phone away. So what we're looking for is the distances are going to be the same. Well, yeah, but that deals with time. The distances have to be the same. And that's the rate, right? That's exactly what it means, right? So we have to look at here now. So the time in which they took off. But the Saab is in the air for 1 hour longer. What was now we have our equation. We have distance equals rate times time. So the distance of A equals the distance of B. Plug in what we know. I mean, you have to look at it in a structured format. You have to deal with what we have. You have to first ask yourself, what is the question asking for? It's asking for time. The time of what? The time when the two airplanes are the same distance of where they started from. So the distances are the same. The times are going to be different because, as you mentioned, they travel at different speeds. So since the distances are the same, that's not even part of the contention. What's because this is rate of the first one times its time, rate of the second one times its time. So what's the rate of airplane A? 517. And the time is just t. The rate of the second one is 290, but its time is time plus 1, since it flew for 1 hour longer than the other one. What do you mean? No, it's always traveling at 290. And this one's traveling. Oh, I see what you're saying. 580. Yeah, it will have covered after 1 hour, it will have covered 580 miles. But yeah, I mean, we can look at it that way. And this one's 517 after 1 hour. So we have to go another little bit further. So let's look how we're going to solve this. So we have 517t equals 290t plus 1. Distribute. We got 290t plus 290. Yeah, so for every hour it travels, why is this 290 here? Because it traveled 290 miles before this one took off. So now we have to solve for t. Subtract 290 from both sides. So we have 227t equals 290. Divide both sides by 227. And we know it's going to be an improper fraction. So yeah, so 227 goes into 290 once. Now the difference is what's important. It's 227 goes into 90, 53. So this is what it comes out to. So this is in hours, this is in minutes. We have to, so what is that with respect to time? Whatever this is, multiply it by 60. Why? Because this unit is in hours, this unit is in minutes. So it's 53 2/27 of 60 minutes. And that'll tell you the number of minutes. So the answer, this is how the answer would look if you use the calculator. So 1 point, whatever that would be. Or 1 hour and that many minutes. So let's say this was 0.37. What that means, it's 37 minutes. 37th of an hour. All right, so that's motion problems. Same equation anytime you deal with anything that moves. Simple interest formula. What is interest? the amount extra over or under the initial amount borrowed or loaned or whatever. In other words, it's the cost of borrowing money. And it's true both ways if you think about it. Whenever you use a credit card, you go to the gas station or a restaurant, you give them your credit card, and that's it. And then you get a statement at the end of the month with a little bit of interest. Because what happened is when you gave that card to the restaurant or the gas station, the company, the credit card company, paid that bill for you. So you're borrowing their money until the end of that month. And then you pay them back a little bit extra for doing that for you. Conversely, when you put money in the bank in a savings account, every month you get interest on that amount. Why? Because the bank is borrowing your money to invest it to make more money for themselves. So they're investing your money for their cause and giving you a little bit of money back for that. So they're borrowing your money, and likewise you're borrowing their money when your credit cards. Interesting how that works. So we have two basic types of interests. We have simple interest and we have compound interest. Simple interest is a one-time calculation of the interest owed. For example, IOUs, which is the reason they call them notes, because back in the old days, you said, I borrow this much money and promise to pay you back this much money, and here's the note, and you sign it. You borrow $100 from me, and you promise to give me back 110 for letting you borrow that money. That's simple interest. It's a one-time calculation. That 10% interest, that's it, no more. Compound interest takes the interest on the balance owed periodically. By periodically, I mean whether it's daily, weekly, monthly, yearly, bi-yearly, it's annually or biannually. So that's why you have to read the fine print. Whether when you borrow money, is it compounded daily, weekly, monthly, or yearly? That has a big effect on what's happening. We're not going to deal with compound interest. This is how the rest of the world, this is how the world works. When you buy a car, borrow, buy a house, use your credit card. Simple interest is a one-time thing. The interest is calculated with this formula. It's interest equals principal times rate times time. Principal is the amount borrowed. The rate is some percent. Some percent converted to decimals by moving the decimal point 2 to the left. And the time is the period you borrow the money. Okay, so that's simply calculating the interest. What you pay back this is what you pay back is this formula. And you see commercials on TV said, if you were in a car accident or something like that, and you were owed this much money, we'll pay you now, and then you get your money now. That's called an annuity. The future amount that this note is worth. So let's say you have a note that's promised to pay you $100,000 in 10 years. So as that goes on, you'll get your $100,000. Well, this company will come in there and say, listen, we'll pay you $900,000 now. And then they'll keep the note and they get that paid with interest later on. So that's how it works. The annuity is the principal plus interest. And if you really want to get shocked, if any of you all have an outstanding balance on your credit card, look at your paperwork and see what they say the interest rate is. The Congress, because they're in the pockets of big banks and big corporations, have lifted the amount of interest that they can charge you on your credit cards. Most of you are probably paying 25% interest on your credit cards, which means for every $1 you pay back the money, 25 cents of it is simply paid interest. So you're only paying 75% of the balance down for every dollar you give. And it keeps on adding because they're going to recalculate the interest later on. So be very careful about that. Which is really frustrating because banks and companies borrow from the government at 1-2% interest. And they turn around and lend it to you for 25% interest. That's criminal. That's why I don't deal with banks. I use credit bureaus or community banks, credit unions. They don't have these big luxury buildings, and they don't have to pay this board of directors. If anybody taken any business courses in here? The way that banks work is they're run by a president of the bank. You have a bunch of vice presidents, each one of them making the millions and millions of dollars. Then they have a board of directors, usually 10, 12 people. Each person on that board of directors gets a huge salary, usually in the millions also. And then if the bank does well, or if it doesn't do well, those executives still get a Christmas bonus in the millions. For example, right now, if you watch the news, there's a strike going on in Boeing because the workers don't get much pay, period. And the executives are getting multi-million-dollar bonuses at the end of the year. Win, lose, or draw, they still get their bonuses, millions of dollars. So that's not fair. That money should trickle down to the workers. So it's going to be interesting to see if Boeing exists after this strike. All right, let's look at example 8, an interest one. Example 8. Demarion's 2 student loans. So we know we have 2 student loans, A and B. Total $28,000. So how do we get that in math? So here's the equation with both. Now we got to find out how they're related. One loan at 5%, let's say this one's at 5%, and the other at 3%. After 1 year, the time is 1 year, Demarion owes $1,040 in interest. So interest equals, what is the amount of each student loan? I thought it was interesting that after the year, they use 1040, which if you ever did your taxes, that's the form you file for your taxes each year, the 1040. So let's see our table here. Note, we have note A and note B. And we know the interest. What's the formula for interest? Principal rate times time. So we have the principal times the rate times the time. And all that equals interest. Do we know the principal? But we know the whole thing. Yeah, so we know the whole thing, A plus B, has to equal $28,000. Since we don't know anything about A and B, we can assume something. The amount that A borrows, let's call it X. It could be anything. So if this A was X, then how much is B? We know together they equal 28,000. So if this one took X dollars of it, this one is 28,000 minus that X. So think about it. If there was $100 and A took 10, that means B would be $100 minus 10. We know their rates. 5% is 0.05. 3% is 0.03, which is 5 divided by 100. What about time? They both were 1 year. And the interest, the overall interest, is that. So what goes in this box? What's the formula for interest? PRT. So we have X times 0.05 times 1. Of course, it's P times R times C. The next one is 28,000 minus X times 0.03 times 1. Together, both of these have to equal those. So what this tells us, we have 0.05x plus 0.03 times 28,000 minus x is equal to 1040. Distribute, get rid of the parentheses. So we have 0.05x, 0.03 times 28,000 minus 0.03x. We got rid of parentheses so we can combine these two like terms. 0.05 minus 0.03 is 0.02x. What is 0.03 times 28,000? So here's 28,000. 0.03 is actually 3 over 100. So 2 zeros are gone. So it's 3 times 280. 3 times 0, 3 times 8 is 24. 6 plus 2 is 8. It's 840. Subtract the 840 from both sides. 0.02x equals 200. Remember, 0.02 is the same thing as 2 over 100. Well, how do we get rid of the 100 on the bottom? Multiply both sides by 100. So it's 2 with 1, 2, 3, 4 zeros. So x equals 10,000. If x, now what does that mean? What does x represent? X represents the amount. So this is $10,000. And this one's going to be 18,000. So the 3% was at 18,000. The 5% was at 10,000. Very good. Now, whenever we have rectangular objects, they can be rectangular, they can be square. We have, in other words, if it looks something like this or like that, we can figure out the area and what's called a perimeter. How do you find the area? We have the base times the height, or length and width. Base times height or length times width. That doesn't matter. It's just two dimensions. The perimeter is the entire length around that object. So if that's B and that's H, so the perimeter would be B plus H. So you add up all four sides. You'll end up with two B's and two H's, or two lengths and two widths, whatever term you're going to use. But you have to add the lengths of the edges. All right. So example 9 says, in December 2009, a solar energy farm was completed at Denver International Airport. More than 9,200 rectangular solar panels were installed. A solar panel or photovoltaic panel converts sunlight into electricity. The length of the panel is 13.6 inches, less than twice the width, and the perimeter is 2007.4. Find the length and the width of the panel. All right, so let's see what we have here. What does it tell us? More than 9,200 rectangular panels were installed. A solar panel, the length, says the length, L, the word is means equals, 13.6 inches less than twice the width. 13.6 inches less than twice the width. And it tells us that the perimeter is 207.4 inches. Find the dimensions. So we have to first write the equation for the length. Length is equal to what? Well, how do we write that in math? So if I give you something, X is 3 less than 5. So what is X? How'd you get 2? I can't see. Tell me how you did. Give me numbers. 3 minus 5 is -2. Is that what you got? So that's not right. How else could you do it? 5 minus 3. So if it's 3 less than 5, that means it's the bigger number minus 3. That's what this is going to be. So it's the width minus 13.6. So now we have the relationship between the length and the width. The perimeter, which is 2 length plus 2W, that equals 207.4. We know what L equals, all this stuff. So put that in place of L. 2 times W minus 13.6 plus 2W equals 2007.4. You could, because the coefficients are twos, since both of these coefficients are twos, I can take them out in front. I can have 2 times W minus 13.6 plus W. That's called factoring, taking out what's in common. Now, since it's in front, I can divide both sides by 2. Two goes into 2 once. 0, 3, 1 left over, 0.7. Combine like terms. We're solving for W. Do what? Next. Add 13.6. Two W equals 13,711. Divide by 2. 2 goes into 11 twice with 1 left over. 2 goes into 17 8 times with 1 left over. 2 goes into 13 6 5. So the width is 28.65. Since our answers are usually one numbers, we will round this one up to 28.7. Because everything is given in one decimal place. So our answers have to be one decimal place. So what's our length? The formula for our length is right here. So it's W minus 13.6. So it's 28.7 minus 13.6. 7 minus 6 is 1. 8 minus 3 is 5. So those are the dimensions of our panels. Example 10. It says Metro taxi charges $2.50 per pickup fee and $2 per mile traveled. Grayson's cab fare from the airport to his hotel was $32.50. How many miles did he travel? let's see, so we have $2.50 pickup fee, $2 per mile. The cost was $32.50. So now let's put that into a math equation. I, we have to set up the equation. The cab fare is whatever it costs to pick up the passenger plus the cost per mile times the number of miles traveled. So this is how that process works. So the cost equals, the pickup was $2.50. It cost $2 per mile for however miles he went. So we know the cost was $32.50 minus the pickup plus $2 for each mile. So this is what he was charged. It was based on the pickup fee plus the, so we subtract $2.50 both sides. Divide by 2. So X is equal to 15 miles. Pretty straightforward. Okay, the last thing for this section, then we'll take a break and then we'll finish up chapter 2, are zeros. Okay, before we do this part, we have to discuss what is a zero. Well, when you have an equation, let's say something like this, it's an equation. You're asked to find a solution. Another name for solution is a zero or an x-intercept. Or a factor. Or a root. Those are all the same thing. They'll be used interchangeably in math. So if I'm asking you to find a zero, I'm actually asking you to find the x-intercept. Well, remember from chapter 1, section 1, how do we find the x-intercept? Nobody here? Yeah, if you spent less time on your cell phones. and more time in your notes studying, you might learn something. Look at your notes. Find me where it says x-intercept in your notes. And it would help in your notes if you highlight different colors on whether it's a definition, an example. You don't have your notes anywhere? You don't write anything down? How do you find x-intercept? Two steps. Set y equal to 0. Solve for x. That's the x-intercept. Again, if I see anybody on the cell phone during this class from here on out, I'm going to ask you to leave because you're not doing yourself any favor. And it's annoying me. If I see anybody on a cell phone in this class. So when we talk about zeros, what we're looking at here is set your equation equal to 0, set the y equal to 0, and solve for x. Subtract 2 from both sides. That's negative 2 equals 3x, and divide by 3. So my 0 is that. How do I know it's a 0? Because if I plug that x back into my equation, threes cancel. My y equals 0. Example 11. Five x minus 9. Find the 0. What do you do first? Set f of x equal to 0 and solve for x. So x equals 9/5. That's my 0. The way it's defined is a 0 is any C value that makes it 0. All right, let's take a 5-minute break. That does it for chapter or section 5 of chapter 1. Let's take a 5-minute break.